Hello dear students, welcome to new video. Today I'm going to explain fundamental trigonometry identities. In order to understand this topic, students, you need to know these four identities in front of you. First one is tan of theta equals sine over cosine. Second one, we have sine theta square plus cosine theta square equals 1. So students, from this one we get the other two identities. By moving cosine to other side, we get sine square equals 1 minus cosine square of theta. And by moving this time sine to other side, we get cosine theta equals 1 minus sine theta. So students, we need to use these four identities in order to solve all the questions in this video. Okay students, first one, we have the style of a question saying use the identity to verify that each statement is true. So from these identities that I showed you right now, you need to show each statement or verify each statement. Okay, first statement, I have cosine theta over sine square theta minus 1 equals negative 1 over cosine theta. Students, this is left hand side, and this is right hand side, right? To prove left hand side equals right hand side, either you need to prove one side. If you get the other side, then it means your answer is correct. For us, it's better to prove left hand side because they contain more stuff, so we can get a right hand side at the end. Okay, students, I have in the left hand side in denominator sine square theta minus 1, which this one similar to the third one, which sine square theta, cosine theta equals 1 minus sine square, right? But here sine square minus 1 actually, not 1 minus. So in this case, we cannot directly say equals cosine theta because the place of 1 and sine theta is opposite. This one, either you can say, if you rewrite like sine square of theta minus 1, this one, either you can factorize negative or rewrite. Let's rewrite in this form. The sign of let's say 1 is negative, so it will be negative 1 plus sine square of theta, right? If you rewrite, because this is positive. So students, here you can factorize a negative, so we get negative 1 minus sine square of theta. True? If you multiply this negative inside the bracket, you get the same stuff back. Okay, so when you get this negative, and we all know 1 minus sine square is actually cosine square, so we get cosine square of theta. True? But this is one of the methods, so directly you can say cosine theta over cosine theta. This is method number 1. Method 1. Okay, this method 1 you can do by this one. Then you get let's say on numerator we have cosine theta all over negative cosine theta square, then cosine with cosine cancel each other, we get negative 1 over cosine theta. This is method 1. Method number 2 that I explained before for you, we can rewrite numerator cosine theta the same, and denominator also negative 1 the same. Okay, instead of cosine theta square, I can write 1 minus, from the identity cosine square theta equals 1 minus cosine, so I can write 1 minus cosine theta square. True? So students, as you can see, we have positive 1 and negative 1. True? So they will cancel each other, so we get cancel out, so we get what we get on numerator cosine theta all over negative, remember this negative cosine square of theta. Students, this look like what? Look like when we have y over y square. True? When you have y over y square. So if you have y over y square, this is y power 1. When you simplify, you get 1 over y. because you will cancel y with y, so you get 1 over it. This is the same thing. Instead of y, you have cosine. So you will cancel cosine with cosine square, you get 1 over negative cosine theta. And we can write this negative on top, like you can move this negative on top, doesn't have any problem. So it'll be negative 1 cosine theta, and this is actually the right hand side. This is how to prove. Okay, this is about this question. About second question, this is similar, students. Can you please, I recommend you to pause the video and try this question first before I explain. Then after solving, come back and play this video. Okay, deal? Right now, pause the video, try to solve this question, then come back. Check my answer. Okay, students. To solve this question, we have same style. You can either, because here we have in denominator cosine square minus 1. This is the left hand side, as we can say. We start by left hand side. We can write sine square of theta, sine square of theta all over. Instead of cosine square, let me write down minus 1. Instead of cosine square of theta, I will write 1 minus sine square of theta. So students, again, remember negative 1 with 1. What will happen to them? They cancel each other. Why they cancel each other? Because they have opposite signs. So usually opposite signs, same value, they cancel each other in mathematics. So we get, but we have, this is power 1. Why I wrote power 2? Okay, anyway. So we get sine theta all over negative sine theta square. So again, same thing, students. This one cancel with the power. So we get negative 1 over sine theta, and this is right hand side. So this is the proof. All right, guys. So we will get, I'm going to explain one more question about this one, but a little bit complicated than this one. Okay, stay tuned. Okay, dear students. This is another method, another question, sorry. We have 1 over sine square of theta equals 1 over tan square of theta plus 1. And the question saying prove this one. Prove that left hand side equals right hand side. Students, in this question, I recommend you to start with the right hand side to get left hand side at the end. You know why? Because it's kind of hard to prove left hand side. It's kind of tricky. So let's start with the right hand side. In the right hand side we have, so right hand side, we start by right hand side. We have 1 over tan square of theta plus 1. Students, remember, in the top I wrote for you, tan theta equals how much? Tan theta equals sine square of theta over cosine square of theta. Sine theta over cosine theta, right? But if your tan is square, so you need to put square for both of them. If it's power 3, so you need to power 3 for both of them. Okay, and so on. If your tan is power n, as example, you will say sine theta power n over cosine theta power n. Okay, students. We have anytime when you see tan, try to open your tan, okay? Try to extend the tan. And let's write down this one in another form. Let's write down this one in another form. On top we have 1, so we can write 1 divided by, because 1 over, this is another note. We have note saying A over B equals A divided by B, right? Numerator divisible by denominator. So this one we can say 1 divided by tan square of theta, then plus 1. Okay, students, right now we have 1 divided by. Try to open tan, value of tan is sine square over cosine square, so I will write down sine square of theta all over cosine square of theta plus 1. Okay, dear students, right now we have something else, note We call this one KCF. KCF. What's KCF? Keep, change, and flip. What's keep, change, and flip? If you have a division, let's say A over B divided by C over D as example. So we will say A over B, keep the first one, change the second one to multiplication, and flip the third one to D over C. So you need to do the same here. We get keep one, multiply by, change division to multiplication we did, and flip. Will be cosine square of theta all over sine square theta, then plus 1. 1 times anything, students, equal the same. So we get cosine square theta all over sine square of theta plus 1. Okay. In fraction, when you have plus or minus, you need to find common denominator. What's the denominator of 1? Is 1, right? So common denominator between sine square of theta and 1 is actually sine square of theta. So let's take another color to write. So you need to multiply this fraction by sine square of theta, numerator and denominator. Sine square of theta. Okay? So let's see what we will get. We will get this fraction cosine square of theta all over sine square of theta plus sine square of theta all over sine square of theta, students. Now these two, they have same denominator, right? So we can write down once. We can say equals, this one equal, so equals, let's erase these lines. We get cosine square of theta plus sine square of theta all over sine square of theta. Students, cosine square of theta plus sine square of theta equals how much? If you remember, in the beginning of the video, I said sine square plus cosine, or cosine square plus sine. In addition, we have commutative. The value equals how much? Equals 1. So that's why numerator directly by identity, this one, all of it equals 1. So final answer going to be 1 over sine . Okay, students, second style in this section that we have of the question saying write down each expression in terms of cosine, or in terms of sine, or in terms of trigonometry. What's that mean? What's this question means? Let's change the color. The question saying write each expression in terms of, let's say, cosine. In this question, terms of cosine, or terms of sine, or terms of tan. In general, when they say terms of something, it means you must have only cosine at the end, not cosine by itself. Maybe plus or minus or divide, multiply by a number. It's okay. We have no problem. But we have problem if you have sine or tan at the end in your expression. For example, if you have cosine, then with tan, cosine with sine at the end. You must have only cosine, but with numbers, we have no problem. We have no problem with the numbers. Okay. First one, let's simplify this expression, tan theta over sine. So I told you can rewrite this one as tan theta divided by sine theta. I think all of you agree with me in this case, right? So remember, students, to open tan always equals sine theta over cosine theta. Okay, so this one KCF, keep, change, flip. So keep first one, change division to multiplication, and the denominator when it doesn't have is 1, so equals 1 over sine theta. Students, when you have in this case multiplication, sine here and sine here, like this is calling cross simplifying. Okay, so you can simplify this sign with this sign, is fine. You get numerator, this one equal on 1, so numerator times numerator, 1 times 1 equals 1, and cosine times 1 equals only cosine theta. Students, do we have tan or sine? No, at the end we have only cosine, and even if it's in denominator it doesn't have problem. So this is going to be final answer. Okay, because finish, we cannot simplify more, and we have only cosine in our expression. Okay, we have second question here. We have sine square theta. We know that sine square of theta in identity is equal 1 minus cosine. So we will write 2 outside bracket minus 1. I will rewrite these two. Why? Because I know that only sine square of theta, this one, equals 1 minus cosine square of theta. True? Okay. Right now, students, in order to find the answer, we simplify, let's say, we must multiply this 2 by both of them. So 2 times 1 equals only 2 minus 2 times cosine square of theta equals 2 cosine square of theta, and we have negative 1 outside. Students, remember, positive 2 with negative 1 equals how much? Equals positive 1. True? So minus 2 cosine square of theta, and this positive we can erase because you don't need to write. We get only cosine in our expression. Students, can we simplify more? No, this is final answer. Since we have cosine, is okay if this one have a power to, as example, have a power to or have 2 or 1 here, is okay as long as we have cosine, so we have no problem. Okay, students, let's solve let's say 2 more questions. This time let's write down in terms of sine. Okay, so let me pause the video until I will write down both questions. Dear students, we have 2 more questions, this time saying write each expression in terms of sine theta. It means you must have only sine at the end. Okay, let's start with the first one. I recommend you to pause the video, solve both of them, then come back to the video. Okay, please right now pause the video, solve both questions, then come back, then play the video. Can you solve? Okay, students, right now let me give you the answer. For the first one, again, this one rewrite, you can say 1 divided by open tan can be sine square theta over cosine square of theta. Okay, then KCF, keep change flip, keep 1, change division to multiplication, and flip will be cosine square of theta over sine square of theta. Multiply 1 by it, we get cosine square of theta all over sine square of theta. But I don't like this one. You know why? Because we have these Mr. cosine square on top. So this is not acceptable, because in the question, as you can see here, saying we must have only sine. So what's this cosine? So you need to use the identity again. So cosine square of theta equals 1 minus sine square of theta. True, students? Over sine square of theta. There's another note. You can never ever simplify this sine square with denominator. Some students, some people, they will cancel. They say, I have sine square on top and sine squaring down, so I can say cancel out equals only 1, and this is actually not correct. This is wrong. You know why? Because this one, let's say the operation between 1 and sine square is negative. Since we have this negative, I cannot directly simplify. If it's a multiplication, okay. If it's division, okay. But directly with addition and subtraction, we cannot do this process. So please be careful. You cannot simplify, and this is going to be final answer. Okay. We have another question, and will be the final question for today's video. We have tan square of theta times by sine square of theta. Dear students, to solve this one, remember between them there's multiplication. Okay, so I will write tan theta equals sine square of theta all over cosine square of theta multiply by sine square of theta over 1. I will not use KCF, okay? Do not say KCF right now. I'm sure you will say KCF because we have multiplication, okay? We have multiplication. Don't have division. So students, this sign cannot be simplified with this sign. Be careful. We cannot cancel out these two. You know why? Because both of them is in numerator, so we cannot simplify it. Be careful in this point. All right. Now, what we do in let's say multiplying fractions, we will multiply numerators together and denominators together, so we get sine square times sine square. It's like x power 2 times x power 2 is equal x power 4, right? So this is same thing, equals sine power 4 of theta. Cosine square theta times 1 equals only cosine square of theta. But again, in denominator we have cosine square. That's not acceptable because we want only sine. So final answer going to be by identity sine power 4 of theta over 1 minus sine square of theta, and this is going to be the answer. I hope you enjoyed the video. Please, for any question, anything, you can write down in comment below, and I hope you enjoyed the video. Thank you for watching until now. Until next video, peace out. Bye bye.